Welcome everybody. This video will be going over task 7 of the NSA 2024 Codebreakers challenge. In the last task, we were charged with identifying a malicious IP that was connecting to a MongoDB instance, and we did this by creating a new user and setting the profiler information to allow us to connect. In this challenge, we'll be tasked with finding more IPs that are on the same network by reverse engineering some of the binaries and exploiting the remote instance. This video will be split up into two parts, or this task, or at least my plan is to have two parts. The first part will be doing the reverse engineering, identification, and enumerating, and then the second part will be the exploitation. So if you're looking for the exploitation, please look at video 2 or part 2. So with that said, let's hop right into the description. So intelligence sources indicate with high probability there's a second device somewhere. We don't know where it is physically, but maybe you can find its IP address somehow. We expect it is one of up to 2 to the 20th devices connected to the Blue Horizon mobile network. Blue Horizon Mobile has explained that their internal network is segmented so all users are in the 10 or 164.0.0.12. That's not going to be a full 256 right here range, so if we have to do anything with that, we got to take note that 64 isn't going to be static. We'll have to need to increase that at some point, or at least some of the bits can be increased. Figure out the device communications with the IP you found in the previous task. It must only do so on demand, otherwise we would have probably discovered it sooner. This will probably require some in-depth reverse engineering and some guesswork. Use what you learned plus intuition and vulnerability research and exploitation skills to extract information from the server somehow. Your goal is to determine the IP addresses for any devices that connect to the same server. There should be two addresses, one for the down device and one for the second device. And then lastly, our Jumpbox account has been updated to allow us to TCP tunnels to the server, and we can reconnect to enable new settings. Remember, the Jumpbox internal IP is 100.127.0.2. So first, let's create our directory, change to 7. I'm going to copy over the Jumpbox key into this directory, and then I'm going to also grab the IP into this directory. Oops, not cat, copy. Don't really need a copy. So IP is just, I just wrote down what the IP was from the last challenge, just because I want to keep track of it. As for SSH tunneling, we can now create a new tunnel. So we do SSH tech I jumpbox key NL localhost. I did a little bit of testing earlier, so I already have something set up. So I do, right now I have 22 set up to just port forward to this address, 22, and then same stuff. The reason I'm doing 22 is because you can do a full port scan of this IP, but all you come up with is port 22. So I'm just going to save us a bunch of time and say port 22 is all that's available for us on this news device. And if we connect to it, port 22, we can see that they're actually running an open SSH instance. If we try to connect to it, localhost is going to say, it probably asks you to verify again. I already did that, but it's going to say permission denied public key. As far as we know, we're missing a public key. So it looks like we need to either identify where a public key is located or try and find some way to bypass this. As we don't really have anything else to go off of, this is kind of where my last gripe with this year's challenges are, because this challenge doesn't really build on the last one too much besides the IP address. I wish it had utilized the MongoDB instance more as maybe a file upload exploit where you have to upload a file and then it gets stored on the attacker server in a file directory path or path directory traversal or something. But it doesn't, so we are stuck with what we're left with. And all we really have at this point is Ghidra. So we know agent is the main binary. I think I already had one open. Not sure why I opened a new one. Close that. Agent is the main binary. We've already gone through upload thread. Didn't look like there's anything else there, so we go back to main. Hopefully this looks fine in the video. Might be a little small. If it is, sorry. We have two left. We have command thread and collect thread. I'm going to hop into collect thread because that's just what's next. And I'm just doing a quick scan of what might be in here. It looks like we read %d bytes from collector at that, do mutex lock, maybe grab some data, another block, and then we run something else. Then while stat on a file, do some kind of system call 23, hex 23. Come look that guy up. 23 looks to be unlink at, so this is just unlinking or deleting the file. Unlink at whatever file it's uploading, I'm guessing, or whatever it's read. Maybe it's trying to store stuff. We have a function called wait for finish. I wonder if that's part of pthread. I don't remember naming anything called wait for finish. I might have. I haven't reversed any of this since challenge 5, I believe. This one also has a system call, 2 of them. This one has 39 twice, it looks like. 0x39 is close, so this looks to be a close system call or function. Maybe there's a good chance this one's open. Too much for us to really care about or look through. Just kind of looking for the high level stuff right now. Some more mutexes. This while loop up here is a little bit different than the last function. If you remember, all the mutex while loop happened first, so this looks like this loop would probably be the mutex comparison in the upload thread. We could try and identify what some of these functions are. Just take a quick gander at all of them. This one just appears to return some kind of data. It's actually grabbing a pointer of some sort. Warning subroutine does not return. It looks like it's the stack canary fails or something. Branch is high. Oh, it's just comparing to the value 1000 or 0x400 actually. So that can't be greater than 0x400. Not sure if that's of any use to us yet. Nothing too... Oh, there's a system call here. Looks like it's calling 48. 48 appears to be pselect. I'm not really sure what pselect does. Synchronous I/O multiplexing. So this might just be syncing up. So I'm just going to go I/O sync. Just looks like it's syncing up with some kind of input-output device to make sure that the data gets read or written successfully. We have another function here. Looks like another just comparison to 400. Another system call here. It looks like 3f. 3f is read. So this looks like a read function. Just check to see the second one's also 3f, so they're both reads. Come down to this one. More just metadata stuff. Gallic, wait for finish. Now that I'm thinking of it, wait for finish might be something we wrote in the main function. Let's check the references to it. Oh, I wish that would have the names on it. I'm wondering if main used that or something, or a different function used it at one point. Probably pthread stuff, possibly. Data barrier. Not sure what that actually does. There's a system call down here at 62. 0x62 is a futex, so this is just kind of locking stuff. I think, is it always 62? That's 62. I think that might be the only one on here. One down here. 62, so I'm just going to call this function futex. Most likely not too, oops, that's fine if we saved. Most likely not too important. Looks like it calls futex again, locks, unlocks, then we close, and then stat the file. Doesn't look like the collector thread really does anything else while it's just collecting data, it appears. So let's go check out command thread. Let's go back to main. Where are you at? Here you are, command thread. Wait for finish, starting command thread. So this might not be wait for finish, might be some kind of printf, since it looks like there's a string at some point all the time. So 2, or it could actually just be the logging print. So it's probably saying only if logging is set to 2 or above or something, print out this string. Or maybe there's optional strings to print. We don't care too much if that is the logging. We have a function here, schedule get priority. It looks like it's trying to prioritize information. Listing on UDP port. Looks like we might be doing some socket stuff here. So system call C8. Scroll down. C8 is bind. That's promising. Bind. We have another function. I'm going to guess this one is probably socket, because we need to create a socket before we can bind. D0. Oh, set socket options, actually. Which I don't think I'm going to be able to create a socket with that. I'm not sure. Maybe this one's socket. Ooh, this one looks beefy. Just scan to see if there's a system call anywhere in here. Close, no cancel, schedule, get scheduler again. Looks like there's internet v6 information there. I'm not seeing any direct system calls, so maybe this is a handler for some kind of socket creation. We could follow the bind function, so if we look at the arguments for bind, bind takes in the socket file descriptor, so we could just follow the first parameter and see where it gets set, and it gets set in schedule get priority max. Maybe you just misidentified this function. So C6. And if it misidentified this one, maybe we need to go back to the other function and recheck some of those functions, make sure everything got set correctly. So socket. So this actually is the socket function, not schedule get priority. That's kind of the downside with this methodology of trying to auto-analyze some of the functions, is that there's a chance that some of them are going to be incorrectly identified. A thunk looks like it's just going to call a secondary function. That might just be the way that the PLT is handled, so not really sure what that is yet. Another function, all it calls is free, and there's a while loop. So maybe it's a cleanup, so maybe something failed. So if we go to this, subroutine doesn't return, so I was going to call this function fail. Let's see, what else? Could not find interface to bind, could not bind, whatever. So it looks like that's all for this function. Where are we at? So let's actually rename this function to setup socket and bind. We can go back to command thread. So we have the socket setup and bind created. Then we have a couple more functions down here. Another 400 hex. Another 400 hex. IO sync, I'm going to check it just to make sure it actually might be that. We have a 4.8, 0x48. P select. So yeah, this is probably the IO sync that I created last time, just to make sure everything syncs up. Looks like nothing. Another 400. Right now, I'm not really sure what those do. They just might be checking to make sure some kind of internal value is correct or that something is set. This one looks a little bit different. It says received %d bytes from %s. So this might be on our socket after something. We could actually follow this. This is probably our socket. Maybe not if it gets overwritten right away. Unless it gets set somewhere else. Our socket could have been set in one of these values too. So maybe one of these functions is waiting for data to come in on the socket. So it's just checking, and then once data is there, because we know a socket is being created at some point, or right there, we're going to be reading bytes. So let's say read from socket, possibly. Both these functions are probably just set up as well. Not sure what you are. Maybe it's the actual read. Maybe it's the checking to see if data is on the socket. So this would be possibly receive. Oh, we have a system call here, CF. CF is set to receive from. Okay, so there's going to be a receive function. Receive parameter 1, parameter 2, parameter 4 into this address. So maybe it's this could be like server information that it received from. Maybe it's keeping track of it. We don't really care anything else about this function because nothing else really happens. It just prints out logs and prints out that we received data. So let's say receive from socket. I didn't mean to rename that one because that's the 400 one. Could rename that to 400, but that's your point. Looks like we're setting some kind of structure memory to 0. Calling this function. Calling internal one. We have close. We have a stat. Supervisor calls 38. 0x38. To open at. So it's going to be open at. So it looks like it stats a file of some sort, checks to see if it exists, and if it does, it opens it and then reads it and closes it. So maybe it's just reading that into memory, and that's what the zeros are being set here for. We had one more function we could check. Looks like it's a thunk, so we probably won't get anything out of that. Go back, set this to read file. We're not sure what file. Right here, even says failed to read file if this returns 0, so that's a good hint that we're reading a file. Looks like we have a string length. We could check it. String length usually has a very similar layout. We had identified this a little bit earlier as possible string length function, I think. We know lvar 5 plus 0x50 is a point or a string of some sort, and it looks like it's being passed in here as a parameter. And is there a chance that that's even read in to from here? Maybe. Not quite possible to tell yet, but it looks like whatever string length is being passed into this function. Looks like this function gets a lot bigger. Get DL main map. 80, that could be a pointer. Let's see if we can identify it as such. It's not like in the 8-byte pointer. I want to set it to a 4-byte pointer if possible. Let's set this to data. Let's just say it's a D word. That doesn't really look like a pointer or anything. Just it doesn't look like a valid address. We can go back. We have a function here. Looks like we're kind of getting into the weeds again, and that's not great. A lot of math stuff going on. We're trying to find something that might look identical. Not seeing anything. I'll check one of these lower functions, see if anything changes. Those are just thunks, so that won't give us anything. Check this one, more math. So maybe it's decryption of some sort, because there's a good chance that any data that gets sent is going to be encrypted. So we're just going to temporarily call this decrypt question mark. And then even here it says got command type S, number of args from variables that are passed in to the possible decrypt function. And then it looks like that string has even been passed into another function, which if we take a quick scan, it looks like there's a switch, so that could be the type or the command it got. Looks like we have a couple of prints. We have an update HMAC key. So it looks like case 2 might just be update HMAC key. Just leave a little comment there. It looks like I actually jumped into the switch right there. Let's hop out. I'm not sure where my comment went. Where was it stored? Oh well, it doesn't matter really if the comment's there or not, because we have this logging print. Case 3, string to lawn, string to lawn. Not sure what that does. Case 4, string to lawn, string to lawn. Case 5 has some more functions. Has a string length, thunks. Based on, case 5, looks like we're stuck in here. based on some data. Another similar string length again. Oh, right here we even have something sent to navigation service. So it looks like 4 sent to navigation service. Are there any other strings on these other ones? Case 7 compares to a null byte a couple times, it looks like. Some string dupes. Oh, this one looks interesting. We have an SSH server address, SSH server port, private key path, SSH username, expected host key, and balloon ID. And it looks like we run execve on wherever ustack11 comes from. Might be passed in, might already be there. ustack18 has a pointer to, oh, look at that, agent diagonal client. So it looks like there's a good chance that all these, probably based on this kind of layout where these are all strings and it's going to be setting stuff to strings, that this is probably set environment variables or some sort, or maybe strcpy. I went count on the strcpy, didn't mean to make that a comment. I wanted to actually make that a function name, but those are looking very environment variable-esque. So let's say set environment, sort of set env. But that's kind of what we were hoping for, because we had an SSH connection, we just don't have any of the other variables yet. So it looks like diagonal client, or diagnostic client maybe, is what we're trying to look for. We have a couple more strings right here, so it wouldn't hurt to look at what these are. So let's open these up in, come over here, go to CyberChef again. Did I miss a character? Make sure I get them all, because if I miss one, it's not going to copy will. Got an extra X on that one. So it looks like we have underscore tornon, but you got to remember this is going to be little endian, so it's actually going to be reversed. So it's going to be non-root underscore something else. I'm actually going to just toss this on a new line. That's going to mess it up a little bit, but if we do fork, it's going to treat those lines as separate. So non-root underscore oot user. So there's a good chance this oot underscore is part of that root, so non-root underscore user. I'm not sure what that means, but if we follow it, it'll be set to param3. Param3 is set right here with nothing else at the SSH username. So it looks like we have a username now. If we come back over here, we can, since we already have the forwarding set up, we could try doing non-root underscore user at localhost. Still permission denied, public key. It looks like SSH server address will be set, server port, private key path, SSH username, expected host key, and balloon ID. So we're still missing some of this. We think we know what the server address is. Server port is probably going to be SSH. Private key path, that one's interesting. As far as we know, for this challenge, we don't have a private key. But if you remember back to challenge 4, when we got this binary, it actually came in, didn't mean to go that far back, came with all these images. So if we go to USB and go to xroot 0, which would be what was private, we actually have a private key sitting in here still. So we could try it with that. I'm going to copy this guy to home Kali Codebreakers 7. Don't need that terminal. Now we have it in here. We can chmod it to 600, because otherwise SSH isn't happy that it's readable or editable by everyone. Try SSH, tac I for non-root underscore user at localhost, and see what happens. Oh, messed something up. Oh, I need to do ID underscore ed25519. And look at that, we even got we're starting to get data back. So diagnostic server starting connection timer. It says it's ready. We're not really sure if we just say hello. Malformed HTTP request, hello. So it looks like it's trying to get some kind of HTTP request, which is interesting. So we could try and make one. Let's wait for it to spin up. Let's do get /HTTP /1.1. So this is just going to be like a default get. Page not found. Content link 19, page not found. So we're not really sure what we could do here. We could spin up a fuzzer of some sort to try and spam this as if it was an HTTP server. It's a little bit slow because it took a couple seconds for it to spin up every time, so that'd be very slow to do. And then ultimately you just won't find anything anyways. So let's try and see what diagonal client's actually doing. We know diagonal client was connecting. Let's see what it was connecting with. So it's another Go binary, if we remember. And we know that it's going to try and grab our environment variables. So it's going to do some OS get environment. This one looks to be a balloon ID. Get environment SSH server, SSH server port, private key path, username, expected host key, and then the balloon ID. And here's kind of another hint that we're using the UUID. Looks like the balloon ID itself is going to be set to UUID, and it's using Google's UUID parse function. If we scroll down, we have a fatal error right here. Failed to parse balloon ID, so that needs to be valid. Looks like we're going to read a file. Not sure what file yet. That could just be, if we do -240, you might be able to follow it back. It might be this one, might be the private key. I'm not sure how reliable these values set within the Ghidra Go comparison actually are, but there's a good chance that they're probably correct. I'm going to check the top to see if there's anything else. Not seeing any real functions. Looks like there's a flag parse. Maybe there's arguments we can pass in. Oh wait, there's even a flag command line function. Nope. Flag command line. Print help message. So there's at least a help. Flag.usage. Has that a pointer? It's a function of some sort. Flag command line? Nope. What this one? Usage of %s, except I guess we could just run it and see what the process says. If I remember correctly, it should be in 5. We copied them over in agent. So if we just run diagonal client, tac help maybe, looks like there's a tac h and tac v for verbose logging. So that's good to know if we're going to run this. With that said, we can go back to main. Because we don't really care about that stuff. We're going to try and follow the actual main meat and see what happens. This main error failed to read private key, so it tries to read the private key around here. Parse private key within the crypto library. We have another error, failed to parse private key, which makes sense. Come down. Main public keys. Not sure what public keys does. Main parse host key. Crypto SSH fixed key. So it looks like we're probably going to do some SSH stuff with the key, which would make sense. There's a random function here. Looks like a structure setup. So when I'm reverse engineering this, I'm just kind of looking for stuff with unique names. So SSH auth method. We could look that up, but I'm going to guess that's just Go's methodology for communicating through SSH, just connecting. This is kind of typical of what form or strings would look like in Go, as Go doesn't keep or doesn't null terminate. The string itself needs to be known the length, and I'm going to guess this one is just %s based on this 2 right here. So this format string is just %s based on whatever data is in brown here or something. SSH dial looks like we're actually going to be connecting to it or dialing in. There's another error, failed to connect to SSH server. We have a main.main function 17. That's unique enough for me to click on. Doesn't look like there's anything in there. But if there's a main.main 17, there's probably going to be other functions as well. So like here's printf3. Printf doesn't usually matter. Create a new SSH session. Error, failed to open SSH channel. Main function 18. Close a SSH session possibly. Continue down, printf, what are we printing? Opened session. Another failed string, enabled standard error logging from server. Keep scrolling down this function. Almost halfway through. SSH session standard input IO write closer. So maybe it's trying to write data to the SSH session. All we need to do is kind of figure out what kind of HTTP a message it's sending and go from there. We have a make slice at this data variable, but it's empty right now, so maybe there's some kind of data it's expecting or it acquires from somewhere. More slices, more converts. We have a buffer IO reader, so it reads something from someone. Makes a slice of it that usually just converts it to a string. That's how I look at it, at least. Those are all probably just structure functions. Nothing to worry, or nothing really to worry about. Main 19. Looks like we have a session run, so maybe it's trying to run a certain command within the session. Let's try and follow that one a little bit. PV var 13, and it just gets overwritten. So it's not really worth following too much then. Have another printf, collect system info. Proc info, so it looks like it's trying to run proc info. It's running a virtual memory library. It's running a disk usage, CPU info, process with context. Process within a while loop, so maybe it's just looping over all of our processes, grabs the number of threads, memories. It looks like it marshals them all together, or joins them all together. That should just save it as one big blob, more or less. Continue through, printf again, see what kind of data it's printing. Writing request. So we're getting close because a request kind of implies an HTTP sort of value. Could not encode status update. That looks like a failure. We have a post down here, so we're getting close. We have this data, HTTP localhost diagnostics. So maybe if we need to... It's weird that it's at localhost, because nothing ever should be at localhost in this scenario. What's the string say? Failed to create request. A dump request out. Garbage. Request bytes %v. Failed to write request to channel. Failed to write request to channel. Wrote request. So at some point between these ones, it must have written it somewhere. Or maybe it's about to and it's logging it. We're running out of functions though. We're running out of binary. Got main function 20. It calls something, but we're not sure what. Could be up here somewhere. We have another failure. Status not okay. Runtime convert. Another failure. Failed to decode next command. So it looks like it might be trying to request a command from the C2, if that's what this is. No next command. It looks like it just says done. Handling next command. And then down here, main run command. So maybe if it gets another command, it runs it. That looks be about it. So at this point, we've seen some more unique functions. So I might come over here and look to see if we missed any. So I might go to main.main. 17, 18, 19, 20 we all checked. Printf functions don't matter, I don't think. They should just be prints. Public keys function 2. Doesn't look like anything. Parse host key. Looks like it just authorizes the host key. So it looks like even the host key needs to be set correctly. Run command. It's going to be run command. Looks like there's some printfs for the run command as well. That doesn't matter. Let's see. Was there anything else that looked interesting? Thought there might have been one, but I'm not seeing any. So with that, we know it's going to connect to the server and try and run a command, or it might upload data and then try to run command. So what we could do is we could just run our diagonal client, set the verbose to verbose, and see if it prints out maybe what kind of post it's doing, what the data should look like. That might give us a hint on what we're doing. But the caveat to that is if we make it look too good, there's a chance that it might come back with a second command because there's code to say command or handle new commands, and we don't want it to possibly run C2 commands on our system. So we're going to go back to our previous task information and use the VM that we'd spun up within QEMU. So if we remember back, this is just going to be the original GDB server that we had connected to that had printed out that we'd used to print out the memory of the running function. So we could actually use this and just spin up our own fake C2 and see what it actually sends. So diagonal client's just by default going to fail, but if we set verbose to possibly 10, it looks like it failed to parse balloon ID. Because remember, we had all those arguments we need to set. So let's go through and set all of our values in memory. So balloon ID just needs to be a valid UUID. So I'm just going to search UUID generator. This could also help us not get C2 if we wanted to against the random thing, or against the C2, as maybe it's based on the UID, and if there's no valid UID, it doesn't work. Accidentally put a backslash. So UID, so that's set. We're going to come over here. What else was needed? Let's go over to agent. Agent had it nicely set up. So we need SSH server address. So this system itself is set to 10.101.255.254, and I think Dropbear should be enabled and running. So yep, SSH is running. So why don't we just use itself as a SSH server? Because maybe it doesn't matter what's actually running there, it just needs to connect to something. So we can say export SSH underscore server adder. Just double check server underscore address. Server underscore address. We'll set this to 10.101.255.254. We could also possibly just do this in our actual system and run it through here, but maybe we misidentified the process while we were reverse engineering it. We just want to be doubly safe to make sure nothing malicious is going to happen. I think we need SSH port, or is it SSH server port? So export SSH server port. Set that to 22. Private key path. This one's a little bit different because we need a private key, and I don't think there's any private keys set up for this current SSH system. I don't know if SSH keygen is even on here. That could be our one caveat, is that I'm not sure if this Dropbear is right now set up to accept SSH keys. So maybe we need to spin it up on our local system instead. So I'm just going to come over here. I'm going to close this jump box because I'm going to apt install open SSH server. Is that already? So let's do sudo service SSH start. It's already, oh, it's already installed. Sweet. And what we can do is just make a SSH keygen, just generate a key, enter the file, sure, set it there, no password. Then we can copy that over to the system. Since it's just a garbage key, I'll probably delete it at some point when I delete this VM. It doesn't matter if I show it. Kali.ssh, don't need home. id underscore rsa.pub. Oh, just that one. Might be a little long even. Let's see, what's the best way? If we have phi, might be able to do that. Phi id underscore rsa. Insert mode. Paste. Cat id rsa. Looks to have worked. chmod that to 600. I don't think that'll matter since it's going to just read it anyways. So now we can set that to export a private key path. Private key path, and just set that to home at ID RSA. Next, we need SSH username, which, in normal cases it would be the non-root user, but here we're just going to set to Kali. Export SSH username equals Kali. If you were, as I'd mentioned earlier, if you're like concerned about this running something harmful, you might not set this up on your own system, but as this is a VM, I can just revert it if something happens. Expected host key. That one's interesting. We're going to figure that one out still. And I think we can do it with SSH keyscan. Keyscan at localhost. One of these will work, the rest will not. I want to say it's one of these two. Let's try this one. I think it's just that, but I don't think it's the whole thing. Export. So the host key is when you SSH in, you usually get that yes or no prompt whether you want to accept a connection. That's what this is. It's just going to have the key on hand so it doesn't have to say yes or no. Export expected key name? Or is expected host key? Expected host key equals this. Oh, did it copy as a new line? That's kind of sad. It's gross. Didn't copy as a new line, copied it as... Oh, it's just failing now. Let's do it over here. Export expected host key equals this. That could just occur as the Kemu process doesn't like the fact that there's a lot of text going on. Puts quotes around this. And when it goes to the new line feed, it might error out a little bit, so it looks a little wonky. So yeah, so that might just because I'm zoomed in a little bit too. So expected host key. We already did balloon ID. So we could try running. I'm going to try SSHing in locally to see if the key works. .shid localhost, make sure that's enabled. Host key failed. Oh, looks like I need to clean this out because I had set up localhost to be the original one earlier. Doesn't look like I have host key or key enabled. Let's go to etc sshd. Whoops. sshd.config or underscore config. Let's set this to be, is it authorized keys? Permit empty password, no. If I do authorized, authorized key files. Oh, I need to open this as root. Sudo authorized keys. Let's see. Let's try that because that might public key authentication. Yes. Let's try that. Then we need to do sudo service SSH restart. Try SSHing in again. Still asking for a password. Might need to Google this one because I don't remember off the top of my head how to enable public key authentication. SSH enable public or private key authentication. SSH keygen. Create the key. We just want to copy it to the server. Blah blah blah. Authenticate with the key. Disable password authentication on the server. So we need to go to password authentication. No, that might be it. Password authentication is already set. Let's just set that to no. Don't think that one matters. Try that. Let's do another sudo service ssh restart ssh tech I. Permission to dive localhost. What if I say specify Kali? That should, in theory, work. Unless, am I supposed to use the public key? No. I'm supposed to use the private key. Oops, didn't want the Ghidra. What am I missing? Because this won't work unless we set that up correctly. So this is just the password. So maybe my process of enabling the other stuff messed it up. I might just turn this one off. I don't know what that one does. That one doesn't look normal. Let's get rid of that. Let's get rid of that. Let's try that one. This in my head doesn't make sense. Yeah, it doesn't work. Why didn't that? Password authentication set to no. I feel like this walkthrough wasn't correct. Key-based authentication for SSH. This looks like the exact same walkthrough. Wow, that was not useful. Let's do sshd_config. Make sure that it's all there. Authorized users. Oh, that might be it. I don't have the public key set in the authorized users. That's right. Let's copy .ssh id_say.pub to home.ssh authorized keys. There we go. Now if we SSH in. Perfect. Logs us in. Okay, so this one, if everything was correct, should be set up to connect when we run diagonal client verbose 10. SSH host key mismatch makes sense. We might just copy the wrong one or just copied it incorrectly. So let's go to key scan again. I think we did this one. So let's try this one now. Export expected host key. We just delete all of this. I think, there we go. Put quotes around this. Copy this whole line again. Paste it, try it again. Doesn't even hurt to actually to echo expected host key. Looks right. If this doesn't work, we'll even include the localhost part, see if that makes a difference. Host key mismatch still. Failed to connect to SSH server. Oh, that's because we're trying to connect to ourselves still. We need to change that so now we connect to this IP, which is at... It doesn't have one. Can we actually pin it then? 101.255.254? Nope. So let's set IP config tap 0 to 10.101.255.253/24. Oops. IF config. Sudo that. Now can we pin it? Can we hit it? There we go. We need to switch the export. Wow, that does not look good at all. Server address 253. This is trying to SSH into the local one. Now it might need to go back to the original or host key. Those actually look the exact same. I just copy and paste the same one twice. Key scan. Oh, there's one up here. Let's try this one again, or for the first time. Export expected host. Delete that. Paste that. Clean that out. Paste it. Run this again. Oh, it looks like we actually got connected and then printed out a big blob. So let's look through the login enabled, connected, open session, enabled standard error logging from server, collected system info, create status update, writing request. Looks like it does request, and then failed to write request, which makes sense because we're not spinning up the HTTP server. So let's see what this request actually is. Actually, with that, I might stop this one and we'll continue this in part 2. So if you want to know what these bytes actually are, you'll have to watch part 2. Thanks for watching.